This event is a conference where students from different grades come together following a theme and find solutions to real life problems using technology. And this year we have MYP4 and MYP3 to be, and this year's theme is robotics for domestic usage. So I will be showing the videos of students from MYP4 and the solutions they came up with. First, I will go with Vedant's solution.
My name is Vedant and I'll be presenting my product for the Design Expo. So we'll first have a look at my design brief. Okay, so the problem my client is facing is when they come late at night from work, or when they out for dinner and come back late at night at 10 or 11 o'clock. It's pitch black, so they can't see anything in the house and they have to turn on the light. But since they can't see anything, they may fall or accidents may happen, causing things to break like flower pots or glasses, or maybe the things they have in their hand may fall. So then my product, which is a smart light and very useful because they turn it off and off automatically, they can turn on according to the time of the day. They can solve my client's problem because they can also turn on if there is any movement in the room. So I'll be presenting my product. Okay, so this is my product. As you can see, this is the circuit of a smart light. The main components that are going to be used here are PIR sensor, which can detect any movement or a presence of something in the room, mainly living creatures, and a photoresistor to detect the time of the day. So I'll start my simulation. As you can see, there's no movement detected in the room, but as soon as there is, my light turns on, and you can also see that it's night time as indicated by the photoresistor, meaning that it will turn on. Now let's say if it was daytime, it's turned off. As you can see, the bulb has turned off, and that's how it works. So like here I just show some movement, and if you can see, the bulb is on. So that is how my circuit works, and now there's not any movement. Yes, thank you. So,
That was an interesting solution. Now I will be sharing Nicole's solution.
Good afternoon. My name is Nicole and I'm from MYP4. This is my design exhibition. So for this exhibition, I wanted to make something related to safety. After doing some research, I found out there was a concept called smart locks, which was really interesting. So I wanted to make a circuit simulation that simulates how exactly a lock system works. So I have done some coding, so there are codes in each of them, how it should function and stuff. So here is the keypad. So you have to enter your passwords here. So for example, how this works is the password for now I have set is 1234. So when I click the right password, it welcomes you back. Now, in case you want to change, so if this is coming as a real product in market and people want to change because every if I am manufacturing this type of a circuit, so I'll keep, as per the coding, I'll keep this as 1234. So many people want to change the passwords. They feel, okay, I want to change this, I don't like this. So there are options, you can change the passwords as well. So I'm going to do the same thing, but I'm going to insert a wrong password. So for example, if I give 9999, it'll say not yours, locked, and it'll again ask for your password. The interesting part about this is, now if I'm turning on the right password again, if you can see, there will be, after you type the right password, this master light will turn on. So the reason why I wanted to make something light up is when you connect this circuit to something you want to lock, when you write the type password, it will turn on. So you can keep this for your main entrance. There are similar things in real life. For example, if you go to a hotel, they'll give you a card. So when you insert the card, the room will unlock and the lights will turn on. You can off the lights later, but the first instinct is when you place the card, it will unlock and turn on the lights. So this is something very similar to that. Thank you.
That was a brilliant explanation, Nicole. Now I'll be playing Arnav's solution.
Arnav Somanchi. Today I will show you my circuit which is powered by USB, which is also linked to an emergency light bulb. This is a solution for emergency power when there is no light available and you have a USB power source, and this circuit will help you to deliver artificial light, which is great and beneficial for emergency situations. So that the way that my circuit works is, once it receives power from the USB circuit right here, you can press the button which will allow the power from your USB source to be transferred to the LED light bulb. And it is very power conservant, as the moment you take your hand off the push button, the bulb will go off. This is greatly beneficial and it can save you time and energy. The time, as in, you will have to press the light bulb in order to get the light, instead of wasting your energy and keeping the light on when you don't need it. In this genius solution, you just need to press the button for the duration of the time you need the light bulb to be on. It is narrated by a resistor which controls the voltage going to the light bulb. So no matter how high your USB how high the power from your USB source is, the Arduino circuit will be able to handle it, as it is safe and secure. Thank you.
That a very creative idea, an interesting explanation. And now I will be moving on to Nana's.
Hello everybody. So I've designed a home automation component which you can control using a remote. You can control your lights, DC motor, gear motor, and vibration motor using this remote. You can control it while you're away from home too. So I first started off by using an Arduino. Then I added 4 push buttons, as you can see, and connected the wires. After that, I added 4 relays on top of the push buttons, and I connected the wires. After that, I added an IR sensor and a remote, and connected the wires to the Arduino. Then I placed a power supply at the top, and next to it, I placed a bulb, a DC motor, a gear motor, and a vibration motor. And lastly, I connected all the wires for it to function. Thank you.
A unique idea indeed. Now I move on to Taran's.
I'm going to be presenting my circuit design for the VGIB design competition. So before showing you guys my circuit design, I will actually be briefing you guys about the components of my design and how my circuit will actually work. So again, hi, this is Taran and I'm from MYP4, and in this project I have made a smoke detector. In the simulation, as the smoke is nearby the smoke detector will detect the smoke and the buzzer will turn on automatically and will make some sort of noise. As soon as the smoke goes away and is far from the detector, the noise will automatically be stopped. Even the indication regarding the status of the smoke, if you're in danger or not, will be displayed on the LCD. So the components which is being used in my design are uh, there's a LCD display over here, there's an Arduino board, there's a breadboard, there are a few wires which are connected from the Arduino board to the breadboard and vice versa. There is a smoke detector and there is a buzzer. Now I'll start the simulation and show you guys how my circuit design will actually work like. Uh, so because the smoke is now nearby, now it will say the in the LCD danger, and as soon as and will make some sort of noise. But now, as soon as the smoke is far away, the noise will be stopped automatically, and the message which will be displayed on the LCD will be out of danger. And now again, if the smoke is near the smoke detector over here, the message printed will be danger danger on the LCD and there will be noise. And now again I have removed the smoke away from the smoke detector, and now the noise will be automatically stopped and the message on the LCD display would be out of danger. To make this circuit design, I have also made a small code which will help the code to work, which will help my circuit to work. Thank you.
That was a fun simulation, great explanation. I will now move on to Ketal's. So now we'll be looking at MYP3 solutions. And first we have Richa.
Hello everyone, I'm Rucha Pagade from MIP Chandra. Today I'm going to share a robotic simulation project for domestic use. It is called Smart to Secure. The design problem. Nowadays, technology is getting advanced day by day. New smart devices are coming up with a lot of advancements. There are various innovations that are now being innovated specifically for domestic use. We all are busy in our school, office, or anywhere else, and we are constantly worrying about our home. When we are not at home, we are tense about the situation at home. As we can't use the camera continuously to see the situation at our house, nor we can have 3 to 4 visits at our home in a day. We should have something innovative, a smart device that can be used as a smart alarm. We can let go these worries with a new innovation, a new smart alarm for a smart house, Smart to Secure. Smart to Secure is a smart alarm system for domestic use, which has few important features that make it a successful smart device. It is easy to use, it works 24/7, and alerts as quick as possible. The success criteria. My target age group is 25 plus. There are few success criteria for the circuit. Arduino Uno R3 board. We need it because we have to take inputs and convert into outputs so that the device works. PIR sensor. We need it so that it can sense or detect the motion. Connecting wires. We need it to make a connection and help the components function as aimed. The buzzer, a sound alert, coding block, and T-bulb, and resistor. This is the circuit simulation. When the sensor detects any motion around, the buzzer is active and it alerts with a sound. These are my acknowledgements. I have referred to few YouTube videos for the product development and used Tinkercad to make the circuit. Thank you.
Great detailed explanation for the problem and solution. Now we move on to Aman.
And today I'm going to show you a door sensor that will beep whenever it sees a person or any creature. So this is my construction. So if I hit start simulating, so this here it will not detect it. Here, slowly the guy comes. And right here, when the person or the creature comes, the buzzer will hit and the buzzer will give signal to the door and the door will open for the man. It's like an automatic door. It will also be used for many things. Like you can use it for windows also. You can use it for many different things like car doors also. So this is a very useful thing.
Again, a very useful simulation and solution and great simulation. And now we move on to Johan.
Did you know that an estimation of 14.2 million households in the United States use robotic vacuum cleaners to clean their houses? But why do so many people use it? This is what we're going to find out in today's presentation. Good afternoon, distinguished judges, guests, and everybody else present in this year's Expo 2021-2022. My name is Johan Rakibe from MIP3 Chandra at MIT Pune's Vishwashanti Gurukul and IB World School. Today I am here to present my research on the product AlphaWise Magnetic. In the United States, the average houses range from 1600 to 1650 square feet. This is equivalent to 2 floors with 4 bedrooms. So, these enormous houses require huge amounts of efforts to clean daily. Additionally, many cleaning supplies or other household products can irritate eyes and throat that can cause headaches as well as other health problems. Moving on to the success criteria for the product. The product should have the ability to clean floors of houses. They should have the ability to clean the windows of houses. They should be remote controlled, and they should have a proper suction system. With the success criteria as mentioned, I believe that there's only one product that can satisfy them all, which is the AlphaWise Magnetic. The AlphaWise Magnetic is a smart window cleaning system which has built-in AI technology that is used to identify window frames and other obstacles while cleaning the house. The solution uses uninterrupted power system, or UPS system for short. It has a powerful suction system and can be remote or app controlled. This is the logic plan for the product. The AlphaWise Magnetic uses a UPS system. It contains powerful suction. It has built-in AI technology as well as it can be app controlled. This is a simple circuit which I've made using the website Tinkercad. Here are my acknowledgements, and thank you so much for listening, and I hope you've learned something about the AlphaWise Magnetic. Oh, and by the way, I'm really sorry, I forgot to demonstrate, but now we're going to start the simulation and see if the circuit works. Okay, so from what we can see, the light bulb lit up, so in other words, the circuit worked, and thank you.
A creative and neat idea. Neat indeed. Now we move on to Bhuvi's solution.
Hello everyone, my name is Bhuvi Vahi and I'm an MYP Sri Chandra. Today I will be presenting my project for the VGIB Design Expo 2022. Let me just share my screen. What is my design brief? My design brief is to create a working circuit in Tinkercad that shows the light circuit. Success criteria. Control over the light switch. And there's a small and practical circuit. There's a series of light bulbs. The solution of the problem is a light bulb circuit. This is my final design. Here it's a 9-volt battery. Here are the wires that are connecting. This is a switch, and these are the light bulbs. My success criteria, I fulfill them all. Control over the light switch. I have the switch. The small and practical circuit. Yes, it is small and practical, and I managed to put the series of light bulbs. Here's the link to my design. It's actually called Smashing Rotis. The Tinkercad auto named it, but I didn't rename it because it's really funny. Now this is how my design is going to work. Let me just tap it. Okay, so right now the switch is off. I'm just going to switch it on. All the 3 light bulbs went on. Off, on, off, on. So now I'm going to explain how. This wire, it takes the current to the switch. When the switch is on, then the current flows from this wire, it goes through there, then it passes through here and then lights up the light bulbs. Then from there it returns to the battery. But when the switch is off, the current flows. It does flow through that wire, but then it returns from that wire. It doesn't pass through the light bulbs at all. Okay. Thank you again.
That was a good idea. Great explanation. And now we move on to Devdutt's solution.
Good evening, respected sir and ma'am. I am here to present you a home security fire alarm. I have made this for age 25 to 35. I have made this, you can use it in office, medical, hospital, school, or factory, and etc. And I will show you how I make this and what products I make you. I'm using an app called Tinkercad in my desktop. I will show you how I did and how this works. First, I will show you what product I have used. I have used piezo LEDs, one white and blue resistor, gas sensor, temperature sensor, Arduino, breadboard, small wires, and I have used different kind of wires to show difference between the wires. And I will show you how I have done coding. I have used text to do my coding. Then I will show you how this works. If suppose there is fire over here, it will not work. When the smoke will come little closer, if it is under the sensor, it will make noise too much of it. It will be far, it will not make. When the little bit of fire is closer, it will be sensor and you can set the temperature. You can set like this. You can use. Thank you, sir and ma'am.
Good job, Devdutt. Now we watch Mishka's solution.
Hello, my name is Mishka Chauhan, and this is my design for the expo. So my design problem was that due to the pandemic, hand sanitizer is kept everywhere in the house. However, there is one issue regarding sanitizer. It is highly flammable. As smoke alarms are expensive, many families do not have it installed in their houses. This can cause many families to lose their homes due to fires. So this was my solution. Therefore, I will design a smoke alarm circuit to prevent deadly fires in homes. So my success criteria: ring buzzer when smoke is detected, and light the LED when the smoke is detected. And to detect smoke can be turned on and off, and when serial monitor is greater than or equal to 400, ring the buzzer. This is my product circuit and my code. I'll just show it to you now. This is my product. As you can see, there's smoke, and when the smoke is near, the buzzer is ringing and the LED is lit up. But when it's farther away and not nearby, it does not ring. Yes, and this was my code. To set smoke to read analog pin, and to print serial monitor smoke with new line, and to wait 100 milliseconds. And if smoke is greater than or equal to 400, then to set pin 13, which is here, and to high to ring the buzzer and light the LED, or just to keep it on low means it will not ring the LED. So my features include, my product has many features. The LED lights up and the buzzer rings when the gas sensor detects smoke. It can be turned on and off. It can be easily made, hence middle-class families can easily buy it as it is cost-effective. Overall, it is a good circuit to detect any smoke. Thank you.
A very useful idea, Mishka. Now we move on to Piyush.
Robots. Robots are a thing which will be replacing most of the tasks and chores of us, which takes longer period of time and reduces our productivity. So robots are playing a major role in replacing them. But what about smaller tasks then? Smaller tasks like watering plant takes up only about 4 minutes every year. Seems a little, right? But combining this every year, you take up 24 hours to water plant. Surprising, right? And speaking about lack of human capabilities, you can't dispense sanitizer or hand wash on your hand with your mind without any physical actions, or you can't spray your surroundings with air freshener with just a single press and it's spreading evenly throughout your home. These small random things are what many robots don't target, as they don't see much of a problem and don't serve a helpful purpose. But these little things are from what a home becomes smart and efficient. To target these small things, I've made a product which targets these small things and makes our house productive while also saving our time. This product's main components work on Arduino board, motors, gears connected with a pulley handle, potentiometer, and a spray bottle. The principal work of this module is very simple. Once the switch is pressed, the gas handle presses on the spray bottle, which dispenses the sanitizer, mist, or water. So this is my product. It has three modules combined into one. It has a mist dispenser, it has an automatic hand sanitizer dispenser, and the third one is a smart machine which waters plant based on the sunlight's intensity. So the first thing I would like to demonstrate is the automatic hand sanitizer dispenser. It has an ultrasonic distance sensor. So when this ultrasonic distance sensor detects your hand under 5 centimeter, it activates the motor. And when this motor is activated, it acts as a pulley on the sanitizer bottle and thus releasing the sanitizer. So when it detects your hand under 5 centimeter, it starts. And the owner can change the amount of sanitizer being released and the time for the sanitization process using the code or the potentiometer. Once this process is completed, the blue light flashes and the vibrating motor starts to vibrate. The second one is the mist dispenser. So it has a switch connected to your switchboard, and the mist dispensers are connected on the top of your roof for even distribution of the mist.
So once this switch is turned on or off, you can see the motor starts to rotate or stop. So it also has a child lock if you have a child in your house which plays a lot with your switch. And it also has a potentiometer so that you can change the intensity or amount of mist being sprayed. And we have a smart machine which waters plant based on the sunlight's intensity. So what is so smart about this? So it has a small photoresistor, and when this photoresistor detects a lot or less sunlight, it changes its resistance accordingly. So if it's a bright day and your plants are feeling dry, the photoresistor can detect this and give more water to the plants by changing the resistance so that the motor rotate faster. But if you want only constant supply, you can change it using the potentiometer.
A very unique idea. And now we move on to Ashna.
Hello, my name is Ashna and today I would like to present to you my model for the Design Expo. The model I have made is a system for a car parking using an Arduino, wires, LED lights, resistors and an ultrasonic sensor, the most important part. An ultrasonic sensor is used to measure distances at different ranges regardless of the kind of object. They can detect approaching objects as well. As technology has progressed, we have become familiar to the use of cars and it has become a very important part of our routines since it's what we use to commute everywhere. Driving the car could be easy, but sometimes people might find it difficult to park as some cars don't have rear cameras yet or people aren't comfortable using it. To avoid any sorts of accidents, they have to keep turning back to look and park at the same time. The circuit I have designed here helps to tell if any object is sensed at the back of the car, which alerts the driver. An alarm and lights will start blinking as the driver gets close to an object. If the distance is okay, only one light blinks, but as the driver gets close, all lights start blinking and the alarm turns on.
A creative and useful solution. And now we move on to Abhiraj.
Hello everyone, my name is Abhiraj Korade. I am an MYP3 Ravi. Welcome to my contribution to the Design Expo 2022. Today's topic is robotics and daily life. The product I chose to make for this expo is a keypad lock. It is a lock which uses password to open. And the reason I made this product is that the normal locks which uses the key/lock mechanism is not good enough and has flaws. Basically, the keys can be made duplicates of. This was my first pick because I also have this tool used to lock my front door. I thought that many people don't have it and should have it. As you can see from this clip, this is my circuit design for the keypad lock. So I clicked on the start simulation to start the simulation of the keypad. And this is my Tinkercad design for my physical keypad lock. I hope you have liked my project and thank you for watching.
A very important solution because safety first. Now we move on to Shambhavi's.
'Hello everyone, my name is Abhiraj Korade. I am an MYP3 Ravi. Welcome to my contribution to the Design Expo 2022. Today's topic is robotics and daily life. The product I chose to make for this expo is a keypad lock. It is a lock which uses password to open. And the reason I made this product is that the normal locks which uses the key/lock mechanism is not good enough and has flaws. Basically, the keys can be made duplicates of.
Great simulation. I think it's a smoke detector, which again, very useful. And now we move on to Adraka.
Hello and good afternoon to one and all present here today. I will be presenting the product that I created, which is a motion detector. The components that I included in my circuit are Arduino, piezo, PIR sensor, wires, and a breadboard. When a burglar trespasses onto a property, the motion sensor detects unauthorized movement that triggers an alarm. Simultaneously, there's a loud alarm playing that helps scare off the intruder. A motion sensor is to detect when someone uninvited is around or in your home, and then this sends a signal to your security system, and if tripped, an alert is sent to you and your monitoring center. According to my research, motion sensors are an important component of any security system. When a sensor detects motion, it will send an alert to your security system, and nowadays with newer systems, it can send that alert right to your mobile phone. Motion sensors have more convenience, and it is energy saving, cost saving, and helps protect your homes. Here is my product. The sensor won't be able to sense motion outside the red boundary, but as soon as it enters the red boundary, it will send an alert to the motion detector center. And as soon as you're out of that boundary, you won't be able to get an alarm. The alarm would stop ringing.
Great description, Adraka. Now we move on to Ria.
Hello everyone, my name is Ria and today I'm going to present a product which is a gas sensor. So like nowadays there are many fire accidents which are occurring. So I thought of designing a gas sensor. The gas sensor will give a notification to the nearest firefighters and to the police. So this is the product. This is the product. This is a battery. This is the sensor and this is a resistor. And thank you.
Good idea, Ria. And now we move on to Trisha. Interesting simulation, Trisha. And that would be it for MYP3 students. Thank you.
So good evening, everyone. This is Ashwini. And thank you, Devanshi, for hosting the event and taking us through the presentations. I think it was a brilliant job done, and being a pilot project, I'm really amazed with the work that has come out. And although I am not much of an engineer, but yes, I can definitely speak about the presentations that happened. And I think we are having some excellent products for moving towards our sustainability development goals. And I think we are catering to SDGs 7, 11, and 12 straight away. So congratulations, children. I think you've done a brilliant job. Keep it up.
Thank you so much for inviting us. And it was an excellent work from the students, seeing and encouraging them during this time. It was, of course, I know that it is difficult to ask the students to think for a creative solutions. So it is about that they are already aware of the problem, but the main thing is to think about the solution. So I think that has given them an opportunity to actually think that what can they do. So that must have generated inquiries in their mind and thinking out of the box to use the simulations and to design a product that is good enough to see that yes, students are encouraged. Also, I would like to thank all the teachers, those who are here to motivate them. Seeing the solutions like smart lights, I really liked, even smoke detectors, things which we every day see and we just give the comment that okay, it could have been, but we don't come up with those kinds of solutions, but students are thinking. So that is actually a really nice work from the students end. And as you sir mentioned that we can actually take up this project to global level, so it will give them those platform and that encouragement to go and to this direction and look forward to more such solutions.
First of all, thank you, Jayanta sir and Devanshi for hosting the event, and congratulations to all the students. I think every single idea was brilliant to come up with these ideas at this age. I think that is extremely wonderful and commendable. And as I must agree with what Amrita ma'am said, that we do see look at the problems around us, and we all think about it. Oh, it could have been something could have been done about it. But there are very few who proactively go ahead and find a solution. These are definitely very relevant problems grounded in real life and very practical solutions that the students have suggested. And now, no product is any good unless it is sold well. So I must commend them on the explanations also that they provided. Some of the explanations were really interesting, and it was really nice to hear because you could identify the commitment that the students have towards the project that they have taken up. So congratulations to the whole team, and I would really, we all look forward to seeing more such events coming from the design department, and we hope that this department would show us how things are done at a global level. Thank you so much.
Looking at the students' presentation, I just found, I think there's one word which describes their work is that creative. Let's say, just like there's a famous quote which says that 1,000-mile journey begins with a first step. I think there's the pilot project what you have taken is very good, and congratulations to all the students and the teachers who worked with them. It's really amazing. It just reminded me that one famous quote, we say that you don't have to be great to start, but to be great, you have to start. And I think the journey has begun, and design is such a fantastic field, right? I say a creative one. Thinking out of the box is never easy. And we, having our own MIT, having our own few design institutes across Maharashtra and Madhya Pradesh, I think this is a very good step which we have taken, and I see that the future is bright, and we will come with far more interesting and challenging topics in the near future. Maybe let's, and I'm pretty sure that under the guidance of our teachers and the students' we'll be fine-tuning the creativity of our students in a much better way in the days to come, sir. All the best, dear students. It's really a fantastic job. I'm really amazed looking at your presentation skills and everything. Right, keep it up.